we're going to talk about similar triangles. When polygons are similar, two criteria must be met. Corresponding angles are congruent. Remember the congruent symbol is equal sign with a squiggly line on top. And corresponding sides are proportional. However, if you don't know the measures of all sides and angles, is there another way to tell? There are several theorems that allow us to show that triangles are similar. There is the angle similarity. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So example 1. Can these triangles be proven similar by AA? If so, write a similarity statement. Example A, we have these two triangles. We have vertical angles, which are congruent, and we have two right angles. So we have two angles. So yes, they are proven similar by AA, and that would be, our similarity statement would be triangle ACE is similar to triangle DBE. In example B, we have two parallel lines. What we learned before about parallel lines cut by transversals is that their alternate interior angles will also be congruent. So first of all, we have our vertical angles, which are congruent, and then we have alternate interior angles, which are congruent. In fact, we have two transversals. So we could mark all of that. But we only need two angles to prove that the two triangles are similar by AA. So these two triangles also are similar. And our congruency statement would be triangle HKJ is similar to triangle HGF. Turn the page. You can also use the AA similarity to find missing measurements in triangles. So example 2. First of all, let's mark that we have vertical angles. And then let's mark our given information. Given that AB is parallel, remember this means parallel, to CD, let's go ahead and write our little arrows showing that they're parallel. And because of that, we just remembered that because if you have parallel lines and transversals, that the alternate interior angles are congruent. So let's put two lines here, and then we could mark the other one if we wanted to with 3. So we know, because of all this, that we have at least two angles, so our two triangles are similar by AA. So now we can proceed and mark our other information. AB is equal to 4. AE is equal to 3x plus 1. CD is equal to 8. And ED is equal to x plus 12. We need to find out what AE and DE are equal to. That means we need to set up an equation to solve for x. We can do that by setting up proportions. We know that these two sides are across from these vertical angles, the angles marked by 1. So those two are going to be, we can set those up in a ratio, 4 over 8 equals 2. Now we can set up these other two sides where we have the unknowns. This side is across from this side with the 3 lines, and this side is across from this angle marked with the 3 lines. So we always go from left to right. So 3x plus 1 over x plus 12, because 8 and 12 are in the same, 8 and x plus 12 are on the same triangle, and 4 and 3x plus 1 are on the same triangle. So those need to be on top, and these both need to be on the bottom. Now we solve for x by doing our cross multiplication. So 4 times x plus 12 equals 8 times 3x plus 1. We do distribution. 4 times x for x. 4 times 12 would be 48. And then we'd have 24x plus 8. Now we're going to solve for x. We're going to move our x's over to one side. So we can subtract 4x here to move it over on this side. And then subtract 8 here and move it on this side. So 48 minus 8 is 40. And 24 minus 4 would be 20x. Divide both sides by 20. And x will equal to 2. We're not done because what they want us to find is an AE and DE. AE equals 3 times x, which is 2, plus 1, so that would be 7. And DE is x, 2, plus 12, which equals to 14. That is our answer to this problem. A second way to show that triangles are similar is by the SAS similarity. SAS is side, angle, side. So in two triangles, if a pair of corresponding angles is congruent and the sides including the angle are proportional, then the triangles are similar. So what it means by including, you've got a side, angle, side, side, angle, side. That angle must be in between the two sides. In example 3, they want to know, can the two triangles be proven similar by SAS? And if so, write a similarity statement. Well, we have two angles that are congruent. They're both 120 degrees. Then we have these two sides. Let's go ahead and circle these. Those are my two shorter sides, and these are my two longer sides. I'm going to put a square around these. So I'm going to do ratios between the two shorter sides, 4 over 6, and then between the two longer sides, 6 over 9. I'm going to find out if they both reduce to the same thing. 2 over 6 reduces to 2/3. 6 over 9 also reduces to 2/3. If you don't know how to reduce fractions, you can always use your calculator and put in 4 divided by 6, and it'll reduce it for you. 2 over 3. 6 divided by 9, 2 over 3. So yes, since they both reduce to the same thing, we're going to say that triangle MNL is similar to triangle PRQ. If you need to pause this video at any time to get everything down, please do that. Otherwise, go ahead and turn to page 8. We have our last similarity statement. The SSS similarity stands for, you got it, side, side, side. So if all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. And they mark these with different symbols, square, circle, and X, to show how they are, how they correspond to each other in the two triangles. So example 4. Are the triangles below similar by SSS? And if so, write a similarity statement. What I suggest doing is finding your two shortest sides, on each triangle. So this is 3, and over here it's going to be 9. And mark them with the same marking. I'm going to circle both of them. Then let's find the two largest sides. We've got 5 here. I'll put a square. And then 15 is the largest over here. So our medium or middle one, I'm going to put a triangle around it. 4, and 12. So that way I can use the corresponding symbols. So 3, set up ratios between the two, 3 to 9, 4 over 12, and then 5 over 15. We're going to see if they reduce to the same fraction. You can do it in the calculator like I showed you last time. And they each reduce to 1/3. So, yes, they are similar. And our similarity statement can be written as triangle TUS is similar to triangle WVX. Now we have several examples down here. I'm going to try to go fast, so if you need to pause, remember you may do that at any time. They want to know if the two triangles are similar. If so, state how and write a similarity statement. We know that we have x, which is the same in both the small triangle and the larger triangle. So let's just put a symbol here. Then we have 80-degree angles in both triangles. So we know that they're similar by AA. This one's fairly easy. Yes, they are similar by AA, and our similarity statements can be triangle XWV is similar to triangle XZY. So that one was pretty easy and straightforward. Number 6, we know that we have this angle that's the same in both the small triangle and the larger triangle. Whenever you see measurements like this broken up, you have the side lengths for the smaller triangle, but you don't actually have it for the larger ones. What you have to do is add. Remember, the part plus the part equals the whole. So 6 plus 3 is 9, and then 10 plus 5 is 15. So let's do our circle, square, triangle, whatever you need to do to show corresponding sides. We know that 6 is going to correspond to 9, and 10 will correspond to 15. So let's see if the ratios are the same. So 6 to 9 and 10 to 15. 6 over 9 reduces to 2/3, and 10 over 15 also reduces to 2/3. So yes, they are similar by side, angle, side. Side, angle, side. This angle is included between the two sides. So our similarity statement will be triangle JLN is similar to triangle KLM. Our last one, we have no angles, just sides. So let's do it by the shortest to longest. Here, 3, 5, and 6. 3 is my shortest. Over here, we need to add these two. 6 and 6 will be 12. So my shortest on this between 6, 10, and 12 is 6. I'm going to circle that one. My longest here is 6. I'm going to put a triangle around that. My longest here would be 12. So put a triangle around that. The medium is 5, put a square. 10, put a square. So let's set up our ratios. 3 to 6. 5 to 10. And 6 to 12. These are pretty easy to figure out. They're all proportional by 1/2. It's a common ratio. So yes, by side, side, side. And our similarity statement would be triangle DEG is similar to triangle HFE. Turn the page, solve for x and y. First we have to know for sure that they are similar. We have this common angle between the small triangle and the large triangle. These two lines are parallel. So I don't have alternate interior angles, but I have corresponding angles. So these two are going to be corresponding, and then these two will be corresponding. So we know that they are similar by AA. Let's add up our long length.